let's have a look at this. What we're gonna have to do is to solve each of the following systems. We are going to use different methods, but before guys actually going into that specific method, I want to remind you something. When solving a system of linear equations with two variables, two equations, we can have different cases. We need to consider two cases. Let's say that I got it. Let me try it here. Let me draw here this the coordinate system here. And let's suppose, guys, that you have two equations. Okay. Let's say that you got two equations and you graph the first equation, and this is what you get. Okay. This is the graph for the first equation, and then you graph another equation, something like, let me think about that, something like this. Okay, guys, and graphically the solution of a system, guys, is this point where the graph intercept each other. This interception point is the solution. Okay, in this case, guys, as you can see, there is just one point, right, where the graph crosses, and you said that there is one solution. Okay, one solution. That could be the first case. What if we have another one? I repeat, this is one solution when they intercept at exact that point, one point. We can have another one. Let's take a look at this. Let me draw this, something like this graphically, right? You can have something like, let me think, you have this equation, and then you have another equation, and you have the same slope, right? You remember that idea. When you have the same slope, what is going to happen, guys? What's going to be the solution when you have the same slope and different y-intercept? Because this y-intercept could be 1 and this y-intercept could be 3. What is going to be the solution for this system, guys, with parallel lines?
No solution.
Solution, because they never intercept. They have the same inclination. They will never touch. Okay, and guys, how can I know that, mister? When you have the same slope, for instance, let's say that this one could be something like y equals to, this is just an example, um, 2x plus 3. This is an example. And the blue one would be something like y equals to 2x plus 1. Take a look. Notice something. You have 2x. This is the slope. Okay, for this particular line, the slope is 2, right? Okay, and for the blue one, what is the slope, guys? What is this slope equals to? It's 2, right? Whenever, guys, you see that you have the same slope, that means the same inclination, and but different y-intercept, guys, they're gonna be parallel lines, but there's gonna be no solution because they will never touch. They will be increasing at the same ratio, but they will never touch each other. This is basically the second idea. No solution when we have the same slope and different y-intercept. And the third case, guys, could be something pretty similar to that. Okay, let me just give you an idea for that. And let's say that I have the equation like something like y equals to, this is just an example, negative 3x plus 2. And the second equation, let me draw that one, okay? Okay, let's see, we're gonna have something like this. Okay, it's negative, right? Can you see that, guys? Okay, it's negative. That means that this is gonna be decreasing. The slope is negative. The graph is gonna be decreasing. And let's graph the second one. Let's say that you got something like, let me think, y equals to negative 3x plus 2. This is my second equation. What is happening here, guys?
The
Both
unique
equations are the
solution.
same, right? Correct. Thank you. Both equations are the same. Then, guys, oh my God, that is awful. So let me do my best for this, guys. Then, okay, sorry. This is supposed to be touching, one overlapping the other one. Okay, guys, the solution is where the graphs touch each other, where they intercept. How many points, guys, do this graph intercept? Many, infinite, right? They intercept at this point, at this point, at this point, at this point, all along this way. Okay, in this case, guys, we say that we have many infinite solutions. Okay, we have many infinite solutions. And this is basically the idea that you have to handle. These are the three cases you may encounter. I mean, you may find when solving system of linear equations graphically. One solution, they intercept at a specific point when they have the same slope but different y-intercept, parallel lines, no solution because they never cross, they never touch each other. And when you have the same equation, infinite solutions. Okay, let's focus ourselves in this particular example. We are asked to solve this system of linear equation, two equations, two variables, graphically. We need to graph. Okay, if I need to graph, you got to graph. Let's label this. I have two equations. I'm gonna say that this is the first one is my first equation. This is my first equation, and this is my second equation. Okay, let's get down to work. Let's copy the first one, guys. We want to work separately. That's the idea, right? When graphically, we need to graph, just like that. You're going to graph separately the first equation, the second equation in the same coordinate system. That let's start off with the first one. Okay, let me take the first one. Okay, let me see. This is my first equation. And I'm going to read it. First equation is 2x plus 3y equals 12. Okay, let me copy that. 3x, 3x, 2x, sorry, 2x plus 3y, that is equals to 12. Okay, guys, when graphing, guys, can someone give me a hand? What is the first thing that I need to do if I need to graph a linear equation?
Let y. So for
Let
like
y alone. Solve for y. As you can see, y is not at all. It's not alone at all here, guys. I have a 2x pissing me off. Okay, let's start working with that, guys. Help me out. Okay, I'm gonna copy 3y equals. Okay, that doesn't look like a y. 3y equals. Take a look that this 2x's, guys, is pissing me off. I'm gonna move it to the other side, and what's gonna happen is positive. On the other side, it's gonna be negative 2x. And this plus 12, guys, I just get it down. It's already here, okay, plus 12. That's what I got. Then, guys, let's have a look here. Why it's not alone yet. Take a look. I got a 3 multiplying. What is the 3 going to be doing on the other side?
dividing.
Dividing. Thank you, Chris. Thank you very much. This 3, guys, is going to be dividing here and dividing here. And then, guys, y is alone, but if we can simplify, let's do it, guys. That's going to help us. Take a look that this negative 2/3 of x is the same. I just copied that. Negative 2/3 of x. And this 12 divided by 3. Can this be simplified? 12 divided by 3.
4. 4.
Correct. And that's what we got, guys. This is what we got. Okay, this is my first equation, guys. The first thing, guys, this is not solved for y. This is in the standard form, guys. That's why whenever I need to graph, I'm gonna be letting the y alone. Now I can identify my information. And what is the most important information I'm gonna need? Give me a hand. That is the y-intercept, the slope, and y-intercept. Thank you. Y-intercept. Give me a hand. What is the slope here, guys? What is the slope? M.
Negative 2. Negative 2/3. Yeah.
Negative 2/3. Thank you. Negative 2/3. And what is the y-intercept? What is the number, the constant term?
4. 4.
Thank you very much. It's going to be 4, guys. With this information, we are completely capable of graphing this. Let's get down to the graph. Okay, we got this slope and y-intercept for my first equation, 2x plus 3y equals 12. Then we're going to graph it, okay? The first thing we need to graph, we're not going to use table. We're going to use instead a slope intercept form. And I need to graph the y-intercept. That's the first thing that I need to plot on my system. Y-intercept is where the graph crosses this axis, which is y. Y equals to positive 4, negative 1 is positive 1, 2, 3, 4. Okay, this is my first point. Okay, let me make that first point right here real quick. Okay, y equals to 4. I'm gonna use the purple one to notice that we're talking about this one. Okay, y equals to 4, and that is my y-intercept. Then guys, from this point I have a slope. This is a slope. This value tells me how should I move in this. It's negative, guys. Should I move up or down when the y-intercept is
Down.
down? How many units?
2. 2.
2. At this point, -1, -2, 2 units down. How many units in x?
3.
3. Okay, 1, 2, 3 in x. I'm gonna have the second point right here. Okay, let me make it the second point. And now, guys, what we're gonna do is we're gonna make a line and we're gonna join this. Alright, this is what we got, guys. I just graphed this, the first equation. Then we need to graph the second one. Okay, we need to graph the second equation. Okay, let me get back to that one. I'm gonna copy the second equation, which is, just one second, the second equation, which is 2x plus 3y equals 12. Okay, let's work. No, sorry. It's negative y equals 2 minus 2x plus 4. Okay, I'm gonna work with the second equation. Let me copy that. Okay, that is 2a negative x. Okay, negative y equals negative 2x plus 4. Okay, I'm gonna work on the second equation. Okay, this is what we got, guys. This one, the second one. Again, whenever you're gonna graph, you need to let y alone. Is y alone?
No.
What is pissing us off? We got a what?
The negative.
We got a negative. Excellent. We got a negative pissing us off. Okay, that negative is pissing me off. Then what are you gonna do, guys? You have this negative one here multiplying. What is that negative one gonna be doing on the other side?
Dividing.
Dividing. Okay, divided by -1, divided by -1. Okay, let's simplify then. Okay, y is gonna be equals to, let's say 2 divided by 1. 2 divided by 1 is still gonna be 2, right? 2x. Positive or negative, guys? You have negative and negative. Positive, right? Okay, the next one, 4 divided by 1. 4 divided by 1 is gonna be 4. And positive divided by negative. That's gonna be negative. Excellent. Now y is alone. Really simple. Okay, let's let y alone. Let's identify the information, which is going to be, let me see, it's going to be m slope. What is the slope in this case, guys? And what is the y-intercept?
2 is the slope.
2 is the slope. I need a fraction. What I'm going to add in the denominator?
1.
Yeah, I'm going to add a 1. Thank you. I need a 1. 2 over 1. And what is the y-intercept?
-4.
-4. Okay, then guys, again, let's plot this in the system and we're gonna graph that one. Okay, using the basic idea. Okay, let me get this a little bit bigger. So we got the y-intercept. The y-intercept is y equals to -4, -1, -2, -3, -4. This is gonna be the first point. Okay, -4 right here. And what is the slope? The slope is 2 over 1. Okay, 2 positive. 1, 2 up from this point. 1, 2, and 1 to the right. Okay, I'm gonna get the second point right here. That is the second point, guys. And then we got, okay, I'm gonna join these 2 points. I can move on, guys, using the slope. From this point, I need to move 2 up. Okay, 1, 2 up, and 1 to the right. I'm gonna get another point right here. I can keep up making more points, okay, according to this slope. From this point, 2 up again, 1, 2, and 1 to the right here, and so on. Let's make the line, guys. I'm gonna join this point, all this point, guys. Okay, let's have a look at this. Okay, I got it. Okay, this is the purple one is for the first equation, and the red one is for the second equation. Okay, how many solutions do we have? One solution, no solution, many, infinite solutions.
One solution.
One solution, because we only have one point where the graph intercept each other, and that is the point, guys. That is your solution, that point. The only thing that you need to do is to find what the point is. Let me zoom in just a little bit here. Okay, let's get into this. Okay, let's see, guys. This point, guys, you need to know what are the value for the point. The coordinate for that values, you will have to know what is x and what is y. Okay, this is x, the first component, and the second component is y. You need to know that, guys, and you know the solution. If that is difficult for you guys, what you're gonna do is this. Let me think. Let me show you how to do that. Okay, what you're gonna do, guys, is you're gonna make this line here. Okay, you're gonna make this parallel line here.
Is 3x and 2y.
Mm-hmm. Okay, you're gonna figure out what is the value. Excellent. Okay, in this case, for x, guys, okay, for x, you only need to move down here. Okay, you only need to move and look what is the value for x, because this is 1, 2. What is the value for x?
3.
It's 3. Thank you. It's the 3, positive 3. And what is the value for y? Okay, you got it to this side. And what is y equals to, guys, in this line? This horizontal, this
Positive
vertical line. Positive what? 1, 2, right?
2.
2. Okay, and that's the solution, guys. 3 for x and 2 for y. 3 comma 2. That's our solution. Okay, let's focus on this. We're gonna use elimination to solve this system of linear equations, two variables, two equations. Okay, this is elimination. What we're gonna do, we're going to eliminate. What we're gonna eliminate, guys, you know that. Okay, let me zoom in just a little bit here. The first thing I'm gonna do is to label these equations. I'm gonna say that this is equation 1, okay? And in order to have a better idea, this is equation 1 and this is equation 2. Okay, and guys, we need to eliminate. The first thing when solving by elimination is to have the system in the standard form. A standard form means, guys, that you have x and y on one side of the equation and the constant term on the other side. As you can see, x and x are here, y and y are here, and constant terms are right here on the right side. Okay, I can add or subtract as I want. That's perfect. Then, guys, take a look at the variables: 3x's and 6x's, 4y and 5y. Which variable do you want to eliminate for x or for y? Someone said x. Okay, Mr. How do I identify which variable should I eliminate for? You can take whatever you want, either x or y. That's gonna work perfectly. But if you want to be clever, guys, if you want to be, I mean, a little bit clever, you can choose, guys, one of the variables. I'm gonna teach you a trick. First of all, if you look at y, okay, let me tell you. Let's say that I want to take the y's. Okay, let me color this. Okay, let's say that we want to eliminate for the y's. Take a look, guys. You have 4y and 5y. Take a look that using 4, guys, and there is no way that you can get 5 because they are not multiple. That's not a good, I mean, thing, guys. That's the first thing. I'm not going to eliminate for y in this moment. Let's see if x is going to work better. Okay, let's have a look at x's. Okay, let me copy the x's. You have 3x's and 6x's. Is there any way, guys, that you multiply 3 times a number and you get 6? Are they
2.
multiple?
2.
Yeah,
Negative 2.
yes, that is the number, guys. That's why we're gonna take the x's. Mister, what if I don't want to take the x's and y, and I want to eliminate for y? It's gonna work, but you will have to multiply the 4 by 5. 4 times 5 is 20, and 5 times 4, right? Do you remember that? Okay, it's gonna be more, guys. That's why I'm gonna eliminate for x. Okay, let me just copy that again here. Okay, I'm gonna copy here 3x's, 3x's, and I have 6x's. Okay, again, my goal is to get 0. And how do we do that? What number should I multiply 3 so I can get 6?
Negative. Negative 2.
Times 2.
It's times 2, thank you. And I need one of them to be negative, right? Because in order to get 0, I need 6 minus 6. Okay, and I'm gonna place a negative for this. Excellent. Negative 2 times 3 is negative 6x. Plus 6x, 6 minus 6, 0. It's done. Okay, let's copy that. Okay, let's copy that.
We
Okay,
multiply the first
the
equation to
first
negative 2.
equation by negative 2. Okay, by negative 2. Excellent. Okay, let me rewrite that. Okay, I'm going to rewrite this, guys. I'm going to copy it right here. Let's multiply. Negative 2 times 3 is negative 6, right? Negative 6x. And then negative 2 times 4. Negative 2 times 4 is negative 8, right? Y equals 29 multiplying negative 2, guys. What is that equals to? is 58, negative 58. Am I right, guys? Yes, right? Okay, that's what we got, guys. Okay, then guys, I'm going to add this, guys. This is gonna be my new equation. I'm gonna add this 6x and this 5y and these numbers. Okay, let me make a line here. Okay, I'm gonna make a line. And if you have 6 apples and you take 6 apples away, what are you gonna get? 6 minus 6?
0.
0. I'm gonna leave this on blank. Okay, if you have 5y and you subtract 8y, that's gonna be negative 3y, right? Negative
Yeah.
3y. Excellent. Equals this number. If you have 43, the numbers, minus 58, these constant terms. Negative 58 minus 43, that is, what, guys, 15? Am I right?
Yes, Mr.
Yeah,
15.
15, negative, right? Because this is the biggest value. Negative 58 is the biggest value, negative 15. Okay, this is what we got. Then, guys, your goal is to let the variable alone. You're solving. You need to let the variable alone. Take a look at y is not alone. How do you let y alone, guys?
The 3 will be multiplying.
Is multiplying on the other side will be?
Dividing.
Divided.
Divided by negative 3. Okay, let's solve that. Y is equals to negative and negative is positive. 15 divided by 3?
5.
5.
5. Okay, guys, we already know the value for y. We know that these values intercept at this point and y equals to 5. But I need to know what is the value for x. Then I'm going to substitute this into the first or second equation. And in that way, I'm going to get what is the value for x. Okay, from which equation do you want to substitute in, guys?
The first
The
one.
first.
Okay, the first one because all of them are positive. Oh, that's really good. Okay, my original equation, the first one is 3x plus 4y equals 29. Okay, let me copy that. Let me copy that equation, which is 3x, let me see. Okay, it's 3x plus 4y equals 29. Okay, then we substitute. Okay, 3x, guys, I don't know what is the value for x, plus 4y. Do we know y, guys?
Yes, 5.
Okay, this y, guys, instead of y, I place parentheses, and y is equals to?
Positive 5.
5. Positive 5. Okay, let me substitute 5 here. And then, guys, this is a combined operation. Your goal is to let this alone. Okay, 3x, guys, let's get rid of the parentheses. 3x plus 4 times 5. What is 4 times 5
20.
equals to? This is 20 equals 29. And then, guys, again, your goal is to let the variable x alone. Move the numbers to the other side, 29. This 20 on the other side is going to be negative 20. And then x is going to be equals to 29 minus 20 is 9, right?
9.
X is not alone. 9 is going to be 9 over 3, right? This 3 is multiplying. And x is equals to
3.
3. And we got the second part, the second component, the first component, by the way. We got our solution for this system, guys. We already know what is y and x equals to. Okay, solution. Okay, solution is going to be an ordered pair. The first one is for the x value, and the second one is for the y value. What is x, guys?
3.
3. And y is 5. If you don't believe me, substitute these values into either first or second equation, and you're going to see that that is true. This is basically what I wanted to explain. That's pretty much it.